question number 77. So the couple of trigonometric identities that we will look at is this. So sine squared of some angle plus cosine squared of the same angle is equal to 1. So if you were to divide completely by sine squared theta, you have 1 plus cotangent squared theta is 1 over sine, which is cosecant squared theta. Now, if you take the first statement, sine squared theta plus cosine squared theta equals 1, and you divide throughout by cosine squared theta, then you'll have tan squared theta plus 1 is secant squared theta. Now, these are the three Pythagorean identities that we have, and let's see how we can use them and some other identities as the case may be to find the values of these problems. So in the first one, the identity that I'm going to use, so I'm going to call this one as my first one, second, and third. So I'm going to use the first identity to find the value of this. So I know that sine squared of some angle plus cosine squared of the same angle is always equal to 1. Then in question number 79, the identity that I'm going to use is that sine of any angle is 1 over cosecant. Likewise, cosecant of any angle is 1 over sine. So they are reciprocals of each other. Now, using that identity, what I can do for 79 is I can write it as sine 80 degrees. Okay. So I can write 79 as sine 80 degrees times 1 over sine 80 degrees, because cosecant 80 is nothing but 1 over sine 80. So this and this gets cancelled away, giving you my final answer as 1. Okay. And then the next identity that I want to use, so let me call this 4. And likewise, I know that cosine is the reciprocal of secant, and likewise, secant is the reciprocal of cosine. This will be my 5. Then I have tangent is nothing but sine over cosine. Okay. And also, tangent is the reciprocal of cotangent, and cotangent is the reciprocal of tangent. Now together, I'm going to call this 6. So if I go to problem number 81, I'm going to rewrite sine over cosine as tangent. So sine over cosine is tangent, and tangent 40 minus tangent 40 is going to be 0. 83, I'm going to write secant, maybe that is, okay. So secant 40. So what is cosine 40? Cosine 400. Cosine 400 is the same as cosine 40, isn't it? Because of the periodic property, if you take away 360, you will get 40. And then secant 40 is 1 over cosine 40. This gets cancelled away, giving you 1 as the answer. 85. Remember, sine is a odd function. So sine of negative pi over 12 is the same as sine pi over 12. And cosecant of 25 pi over 12 is the same as cosecant of 24 over 12 is 1 revolution, 2 pi, plus pi over 12, right? So this is the same as cosecant pi over 12. Okay? So if you recall this, I can rewrite this as cosecant pi over 12, and cosecant pi over 12 can be rewritten in the next step as 1 over sine pi over 12, and these gets cancelled, giving you 1 as your final answer. Okay. Okay, that takes us to 87, and 87 is sine of negative 20 is sine of 20 degrees. Cosine of 380 is the same as cosine 20. plus tan of 180 is also tan of 20 because the period for tangent is 180 degrees. Now sine over cosine is tangent. So you have tangent 20 plus tangent 20 is 2 times tangent 20 degrees. Okay. Then takes us to 89. In 89, what you're asked to do is you are given the value of sine theta and you have to find the value of the following. Okay. So you remember that 2 pi is the period for sine. So every 2 pi, the same value is going to repeat. So if sine theta is 0.3, right, then I will have sine theta plus 2 pi is also 0.3. Sine theta plus 4 pi is also 0.3. And 3 times 0.3 is 0.9. 91 is tan theta is 3. Again, the period for tangent is pi. So the values are going to repeat themselves. So this is 3 plus 3 plus 3, which is 9. So then cotangent is, so you see that whether you go pi in the forward or pi in the back, it's the same thing, right? So this is also going to be the same. So you're going to have -2 plus -2 plus -2. Okay. So the reason is that, so if you have, say your angle is somewhere here, right? And then if I want to find 80 degrees going in the opposite direction, right? So you're going to end up somewhere here, right? So that's where you're going to end up. So in those two quadrants, right? The first and the third quadrant, the cotangent or tangent is still going to have the same value. If it is positive, it's going to be positive. Negative is going to be, I'm sorry, they're both going to be positive and positive. It was first and third, and if it was second and fourth, it's going to be negative. So this answer will be -6. Then I have question number 93. This one. Okay. The question is asking you to find the value of sine 1 plus sine 2 plus sine 3 plus so on till sine 359. Okay, so now here in this problem, what you want to see is, so basically what this is asking you is, so here 1 degree is somewhere here, right? So 1 degree is somewhere here. Hmm. So 1 degree is somewhere there. So remember, sine is positive in the first and second quadrants, and in the third and the fourth, it is negative. Now, this is how I'm looking at this problem. So I'm just going to talk you through how I think about it. Maybe there is some other better way of doing this, but this is how my brain thinks. So this is 1 degree, correct? And so, and then you have, this is 1 degree. So all of this from here, from 1 to up until, say here, 179, these are all going to be positive values. Sine 180 is 0. So these are all positive. Now, for each of those positive values, we are going to have negative values on the bottom two quadrants. So that means 179 is going to have an equivalent value at 181. Now that's going to get cancelled away, a positive and a negative. So basically what happens is all of these values are all going to get cancelled away, right? So this will neutralize with this, so gone. Likewise, this will neutralize with this, positive and then negative, right? So they're all gone. So the net answer, if you add them all up, should be 0. Okay, 95. What is the domain of a sine function? So this domain of a sine function is all real numbers. So you can input any angle into a sine function. For what numbers theta is f of theta equals tan theta not defined? So remember, when is tan theta going to be not defined? Tan theta is going to be not defined whenever cosine is zero because tan theta is nothing but sine over cosine. So whenever cosine is zero, it becomes undefined. Now, where does cosine become zero? So if you look at this, cosine is going to be zero at all the odd multiples of pi over 2, right? So pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, negative pi over 2, and so on. So I will say for what values of for what numbers theta. So when theta is odd multiples of pi over 2, where k is any odd integer. Okay. Then I'll go to question number 97. Oh, that's what we did now. Then we have question number 99. For what numbers is secant theta not defined? Now, secant theta is going to be the same, isn't it? Because it is 1 over cosine theta. So because it is 1 over cosine theta, the same restriction is going to happen here. So for question number 99, I would still say that k cannot equal, uh, so basically what I'm saying is it is undefined when theta is k over k times pi over 2, where k is any odd integer. Okay. And then 101, the question is what is the range of the sine function? The sine function range is negative 1 to 1 because as you can see from here that if you follow sine as all the vertical distance, so the vertical distance goes from 0 to 1 to 0 to negative 1. So the highest value it is reaching is 1 and the lowest value is negative 1. Then the last question 103, what is the range of a tangent function? Now tangent function range is all real numbers, negative infinity to positive.